Hello and welcome to the BMC Quick Course Series. In this session, I'll show you how Change Manager for DB2 has enhanced the continued support for OLS changes and reorgs when modifying DB2 structures. As you know, DB211 introduced new online schema alters for limit key changes and drop column. They also made enhancements to Reorg to allow the automatic creation of a mapping table and allow you to specify the default mapping database if you wish. We support these features, and I will be showing you how this is done. We have also enhanced support for both DB210 and 11 to further exploit the changing world of DB2. We will generate share level change or reference reorgs to resolve reorg pending changes. We may generate multiple reorgs on the same table space to allow complex changes instead of doing an unload, drop, create, and load. Here's a list of the topics we will be covering here today. There are new and changed sections in the work list. There are new behaviors based on options specified. There are new options to control new features. Let's jump in and take a look at the details. When you ask Change Manager to convert an index-controlled partitioned object to be table-controlled, we will always use the non-disruptive alter index method to do this. We will no longer use the alter table, alter partition method as it puts the last partition in reorg pending status, and it may not be allowed based on the restrictions that can be set with IBM APAR PM89655. As you know, limit key changes on table-controlled partition objects are now pending DDL alters in DB211. To support this, we have separated out the alters for limit keys and add or rotate partitions from the other table alters. These are now in their own sections in the work list. In DB210, the limit key alters will always be done before the add and rotate parts alters. Doing them in this order ensures that the alters will be successful. In DB211, this same approach is not possible. The limit key alters are now pending DDL. Immediate alters to add or rotate parts cannot be issued if there are pending DDL alters. We will verify limit key values to ensure that there is no overlap on the new values. If there is no overlap, then we will do the add and rotate parts first, followed by the limit key alters. In DB211, we have a new situation we need to detect. This happens when you are making changes to the existing last limit key and you are also adding parts or rotating parts. This was not a problem in DB210 because all alters were immediate alters and they could all be issued and followed by a reorg. When you are making this type of a complex change in DB211, it could be problematic. If the existing last partition limit key is changed to a lower value and the limit key value on the first added or rotated partition is less than or equal to that original last part limit key value, you have an overlap. If there is an overlap in DB211, the limit key change must be instantiated before the add or rotated parts can be done. The alter to add or rotate part would fail because the limit keys specified would require that the new last part limit key be in place. So let's look at some overlap examples. First, we will look at a limit key overlap that involves adding a partition. So here you can see the original limit keys in the upper part of the screen. In the lower part, you can see the new changes specified to modify the last partition limit key and add two new partitions. As you can see, the limit key for part 5 was changed from F99 to F55. The new value is less than the original value. And you can see that the new part 6 has a limit key value of F99, and that is equal to or less than the original last part value. This is an overlap, so what happens now? We will detect this in the analysis process with an E-level message. We cannot proceed without additional direction from you, the customer. Let's look at the choices you are presented with. Because there is an overlap in the limit keys, you need to investigate and provide direction to ensure that there is no data loss when implementing the desired changes. If there are rows of data that exist in the overlap, rows with limit key values greater than F55 and less than or equal to F99, you must manually add the allow rebuild keyword to ALUIN and rerun analysis. We will do an unload, drop, create, and load to implement the change. This is the only way to avoid losing those rows. If there are no rows of data that exist in the overlap, rows with the limit key values greater than F55 and less than or equal to F99, you can manually add the allow reorg keyword to the ALUIN and rerun analysis. We will then do the alter limit keys followed by a reorg. Then we will do a late add part after the reorg is complete. Here is what allow reorg would look like in the work list. You can see we provide an informational message noting that allow reorg was used. Next, you see the limit key alters followed by a reorg and then the late add partitions. Now here is what allow rebuild would look like. Again, an informational message noting that allow rebuild was used. Now you see the unload, drop, create, and load. Now let's look at a rotate parts with overlap example. So here you can see the original limit keys in the upper part of the screen. In the lower part, you can see the new changes specified to modify the last partition limit key and rotate one partition. As you can see, the limit key for part 5 was changed from F99 to F55. The new value is less than the original value. And you can see that the rotated part has a limit key value of F99, and that is equal to or less than the original last part value. This is an overlap, so what happens now? We will detect this in the analysis process with an E-level message. We cannot proceed without additional direction from you, the customer. Let's look at the choices that are presented to you. Because there is overlap in the limit keys, you need to investigate and provide direction when implementing the desired changes. If there are rows of data that exist in the overlap, rows with limit key values greater than F55 and less than or equal to F99, we cannot perform all the changes desired in one work list. If you want to implement the changes, you must do this with 2 work lists. The first work list would need to implement the limit key changes. Note there will be discards. The second work list would need to implement the partition rotation. If there are no rows of data that exist in the overlap, rows with limit key values greater than F55 and less than or equal to F99, you can manually add the allow reorg keyword to the ALUIN and rerun analysis. We will then do the alter limit keys followed by a reorg. Then we will do a late rotate part after the reorg is complete. This is what allow reorg would look like. You can see we provide an informational message noting that allow reorg was used. Next, you see the limit key alters, followed by a reorg, and then the late rotate partition. There may be times when pending DDL changes need to be instantiated before additional alters can be successfully performed. For example, you may have an ICP object that was created without specifying a DS size or large. In this situation, the ability to add partitions will be limited once it is converted to table-controlled partitioning. That limitation goes away if the object is converted to a partition by range universal tablespace. This is a scenario where we would need to do the pending DDL alters early and then instantiate them with an early reorg to convert it to a PBR UTS. This would be followed by subsequent alters that can now be performed on a UTS. This is how that might look in the work list. You can see we provide an informational message noting that an early reorg was used. You can see the early OLS alters to seg size and DS size, converting to a UTS. These early OLS alters are followed by an early reorg. And finally, you see the alters to add parts. The tablespace can grow because it is a UTS with a DS size that will allow it to grow. IBM now allows reorg pending status to be cleared by using any share level. This changed at some point in DB2 10. Prior to the change, the reorg had to be share level none to clear reorg pending. We now support the use of any share level to clear reorg pending. Another reorg change with DB211 is the automatic allocation of a mapping table and a related new keyword, mapping database. In DB211, the mapping table LRSN column length must match table space. So why worry about this? DB2 will automatically allocate the table space table and then delete it when the reorg is complete. You can specify a default mapping database or allow DB2 to use an implicit database. We have support to allow you to exploit these features. In the product options file, we have the following variables you can specify to control mapping keywords in your share level change reorgs. Reorg_mapDB. Specify a default database name if you want the mapping database keyword included in your reorg. Leave it blank if you want to omit the mapping database keyword. We continue to support the following variables for mapping table. Reorg_mapTAB. Specify a value if you want a mapping table keyword included in your reorg. ACM_IBMR_map_REQ. Specify Y if you want the mapping table keyword in your reorg. Specify N if you want the mapping table keyword omitted from your reorg. Here is the options panel where you can specify a value for mapping table or mapping database. Here is the options panel where you can specify to omit the mapping table keyword from your reorg. These are the values you would want to specify if you want to have the mapping table keyword included in your share level change reorg. These apply to both DB210 and DB211. These are the values you would want to specify if you want to have the mapping database keyword included in your share level change reorg. These are the values you would want to specify if you want to omit mapping database and mapping table keywords in your share level change reorgs. These apply to DB211 only in any mode. Remember, in DB210, you must have the mapping table keyword on a share level change reorg. In DB211, you have three choices. Omit both mapping database and mapping table, have mapping database only, have mapping table only. As you have now seen, there are many OLS and reorg related enhancements and improvements in Change Manager for DB2. Thank you for your time. For more information on any BMC Change Manager feature, please visit the quick courses in this series.